Hello guys, so today we are going to continue where we left off on Friday, and that's with comparing populations. Okay, we don't compare populations by just looking at them anymore. We need to have the math behind it why we are comparing, because again, we want to be unbiased. All of our data, all of our answers needs to be unbiased, means nothing to do with our thoughts and feelings and everything to do with the numbers and that what we take from the survey. Okay. Here's how we compare populations. If they're symmetrical, and I'll go over what symmetrical looks like, we use mean absolute deviation. I'll go over what that means. Okay, don't worry, I'll go over what it means. If it's skewed all over the place, not consistent, we use median, middle, and interquartile ranges. And I'll go over what that is as well. So let's get started with example 1. Right now, we are going to compare the populations. Here is what we are looking for. Is it skewed or is it symmetrical? This is symmetrical data. So we are going to use mean, average, and we are going to use MAD, mean absolute deviation. And I will go over what that is. So let's compare the populations by the mean first. We're going to start with mean. So A, the mean, is we add up all of these numbers and divide by how many there are. So I'm going to go through, pull up my calculator, and I'm going to do right here 50 plus 260, 60 plus 60 plus 270s plus 70 plus 70 plus 380s plus 180, 280s, 380s plus 390s, 2, 3 plus 100 plus 2 110s. Oh no, I made a mistake. I need to go back and fix that. Minus 1 1 0. Okay. Plus 1 10 plus 1 10 plus 120. Okay. So our mean for the first set is 1,260 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 15 questions. 15. Which is 84. Okay, our average question time is 84 minutes. Wait, the double shows the time. Yep, time. Yep. Okay, now your MAD is now going to calculate the absolute value between the mean and all of the other points. So right here is 84. Okay, so our first number is 50. So we're going to find the distance between 84 and 50. What's the distance between 84 and 50? We write it like this, 50 minus 84. And there's only one of that. Plus the distance between 2 60s and 84. Plus the distance between 2 70s and 84. Plus the distance between 3 90s. Oh my goodness, 380s, and then 390s. 380s minus 84, then 390s and 84, then 100 and 84, then 2 110s and 84, and 120 and 84. Okay, if you can do that distance in your head, you don't have to do this work. The last thing we're going to do is divide by how many questions there are, which is 15. Okay, so the distance between 50 and 84, 50 minus 84 is 34. Absolute value of 34 is 34, plus 2 times 60 minus 84, 60 minus 84, 24. The absolute value of negative 24 is 24, plus 70 minus 84, 14, take the absolute value of it, oh man, 2 times 14, plus 3 times 4, plus 3 times 14, plus 16, yep, 16, plus, 1 second, alright, so, plus 2 times 110 minus 84, 110 minus 84 is 26, plus 120 minus 84, 120 minus 84, the absolute value keeps it positive, 36, all over 15. All of this work is helping us from being unbiased. Okay, so we have to be using this work right here. Okay? Now, all of this multiplied and added together is 244 divided by 15, which is 244 divided by 15, 16.6 repeating. Okay? 16.6 repeating. We're going to get to what that means. I need to erase my board a little bit to give myself room for part B. All right, now let's look at population B. Let's find the mean. We're going to add them all up and divide by how many there are. Okay, so we have, oh, I don't know why I keep Xing on my calculator. $30 times 3 plus 40 plus 50 plus 50 plus 1, 2, 3, 4 60s, which is 240, plus 140, 2 70s, plus 80, plus 2 90s, which is 180, equals 870. So 870 divided by 15 equals, divide by 15, 58. The mean is 58 minutes here. Now let's find our MAD. This is what takes a lot of work, but helps us from being unbiased, helps us from being biased. We're talking about the distance from each point in 58. So the distance between 30 and 58 is 28. So now I'm just going to look at that. And there's 3 of them. So 3 times 28 plus, I got those 3. 40 and 58, the distance is 18. Plus 50 and 58, there's 2 of them, and the distance is 8. Plus 60 and 58, 4 times 2. The distance is 2. And there's 4 of them. Plus 70 and 58 is 12, and there's 2 of them. Plus 80 and 58 is 22, and there's only 1 of them. Plus 90 and 58 is 42, and there's 2 of them. So after we're done with all of the multiplication and adding them and dividing by 5, we get that the MAD score is 236 divided by 15, which approximates to 16. Both of these approximate to 16. Okay. Compare the population using centers of variation. There's our centers of variation, centers and variation, centers and variation. This variation is 16. All we would need to do now is write that the variations were the same, but the means, candidate A had the higher mean. Okay, now express the difference in the measures of center as a multiple of measures of variation. Let's talk about what that means. All that means is express the different centers, 84 minus 58, as a multiple of the variation. The variation is 16, and we get that 84 minus 58 is 26, and 26 divided by 16 is 1.25. So 1.625, okay, is the multiple. Okay? That's the difference between the two. All right, let's go back to example B. Here's how we compare with skewed data. These are box and whisker plots. I'm not asking you to make them. I'm just asking you to be able to read them. So we use median and interquartile ranges for skewed data. The median is still the middle. Here's the middle. Here's the middle. Here's the middle. Here's the middle. So we're looking at the middle. Okay, you want to compare the cost of spending tickets in 2 states. The double box and whisker plot shows a random sample of 10 speeding tickets issued in 2 states. Compare the samples using measures of center variation. That's the mean. The variation is the interquartile ranges. Can you use this to make valid comparisons? The answer is yes, because they're unbiased. Okay, explain. All right. Now, I need to go back and retract what I said over here. I went back and thought about that. Can you use this to make a valid? Remember when valid is talking about random and enough, an amount. Random, an amount. And we'll get back to that. Okay, so the center is your median. So for state A, the median is 70. And the variation, the interquartile range, is the distance between the very first one and that middle number, which is 20. Interquartile range, 20. Okay. State B, the median, the middle, is 80. And the interquartile range is from this point right here to this point right here is 10, 20, 30. Okay. Compare the samples using them. Here's the means. Here's the interquartile ranges. Can you use this to make it valid? No, because 10 speeding tickets are not enough, and we don't know if, we do know it's random, but 10 is not enough for a state. All right, part B, let's look at this one. Looking at the double whisker plot, okay, shows the medians, the middle of 100 random samples of 10 speeding tickets for each state. Compare the variability of the sample means to the variability of the sample cost in part. Okay, so we're going to compare the medians between state A and state B. So the median here is about 65, and the median here is 80.